Hello, everybody. So today we're going to start into Chapter 7, Section 2. This is just a continuation of what we started discussing in Chapter 7, Section 1, which the main point of that section was to start discussing exponent properties. So I'm going to show you some more exponent properties, and we're going to use those properties to simplify more algebraic expressions. So here are the new properties for this section. There are four. The first one is called the quotient. The second one is the power of quotient. The third is the zero. And then the fourth is a negative exponent. It just says negative, but it's a negative exponent. So I'm going to show you an example of each one of these right beside the actual property you see listed so you can understand what it means. So the first one is, excuse me, when you have a quotient, which means you have an expression that is being divided, and that expression has the same base. So the base, it could be a number or it could be a letter or variable. But what you are allowed to do to the powers is you're allowed to simply write one of the bases and then just subtract the two powers, m minus p. So as an example of that, if I had x to the sixth power and I was dividing that by x to the second power, you can see that the bases are the same. So since the bases are the same, I can rewrite it as 1x and then 6 minus 2. That becomes x to the fourth power. So it's pretty simple that you just subtract. Remember, we had before in the last section, if you were multiplying, you would add the bases up. So when you multiply the bases, you add the powers. In this example, when you divide the bases, you subtract the powers. Okay. Now the next one is called the power of quotient. Now the power of quotient means that if you have two numbers or variables that are being divided, and then the whole thing is being taken to a power m, you are allowed to distribute that m to both the numerator and the denominator. And you can see it becomes a to the m, b to the m, like that. So an example of that would be something like x over y to the fourth power. We can rewrite that as x to the fourth over y to the fourth, just like that. Now, the next one is a really simple property, and it's a really powerful property. It is very helpful when we are simplifying these algebraic expressions, and that is that anything to the zero power is 1. So you can see an example right here. We have b to the zero power, and b to the 0 is 1. If I had 2 to the 0, that is also 1. I know it seems counterintuitive. You would think anything to the 0 power would be 0, but it's not. And I'll show you why. I'm going to use the property that we have up here, which is the quotient property, to show you an example. So if I had 2 to the third power divided by 2 to the third, there's two ways that I could expand this, okay? The first way is I could actually multiply out 2 to the third. 2 to the third is 2 times 2, which is 4, times 2, which is 8. So this expression essentially means 8 divided by 8, which is 1, okay? But here's another thing. If you look up here at the quotient rule that we have for exponents, that says that if you have the same base, you can subtract their powers, which we have the same base here. So this would actually turn into 2. I don't know why I'm having problems with my stylus. I apologize. But try it over here. It's not letting me write down there. Let me move it. 2 to the 3 minus 3. Now, 3 minus 3 is 0. So what you've found now is that we've taken this expression 2 to the third power, and we have simplified it in two different ways. First, I just expanded it into its regular numbers, which is 8, and 8 divided by 8, which is 1. And then the other way I did it is I utilized the power down here, and I had 2 to the 3 minus 3, which is 0. Now, in showing you that, what you end up seeing is that 2 to the 0 power is 1. These are equivalent. Okay. Now, the last example I want to show you as far as the exponent powers go is this one right here. I have b to the negative m equals 1 over b to the m. Now, what I'm going to use for that is, or what I want you to see, is that this allows the power and the base to move positions. So if I have a negative power like 2, um, 2 to the negative 3 power, that is equal to 1 over 2 to the third. So when the power is negative, it moves the whole base and the power down to the bottom. Now, in a similar fashion, if you had 1 over 3 to the negative fourth power, that is equivalent. You could take this whole thing and move it to the top. So basically, a negative exponent means you are allowed to move it from the top to the bottom of a fraction or from the bottom to the top of a fraction. And understand that whenever you simplify algebraic expressions, the most simplest form is not allowed to have any negative exponents in it. So let's give this a try. We have this first expression. We have x to the third, y to the fourth, over x squared, and then y. First thing I want to see you do is go ahead and put in a first power for the y, if you have that, because you should always write in the first power if it's not there. So we're going to call this first power. So there's y to the first, okay? Now the next thing to notice is that we are dividing. So since we are dividing, we are going to go ahead and subtract. It's going to become x to the 3 minus 2 times y to the 4 minus 1, just like that. Now 3 minus 2 is 1, so this becomes x to the first power, and then 4 minus 1 is y to the third power. And there's our final answer in most simplest form. So when you are dividing the same bases, you can subtract the numbers. Okay, so the next one we're going to try here is we have k to the 7th, m to the 10th, and it's divided by k to the 5th, m to the 3rd. So this one's going to be done in a similar fashion as the last one. You can see we have the same bases here, k's and we have m's, and so they're being divided. So because they're being divided, we will subtract. So I'm going to first write k, and it would be 7 minus 5, and then it would be m, and it would be 10 minus 3. And so then the final answer is going to be k to the 2nd, m to the 7th. And there's your most simplified form. Now, moving on to the power of a quotient. So as I showed you up here, if you have a quotient and it's being taken to a power, in this case m, this m can go to both things that are inside the set of parentheses. So that's what we're going to have for this one. So you can see we have this expression 3x to the 4th over 4, and it's all being taken to the third power. Now, as I said in a previous video, and I showed you even in previous examples, if you don't have a power on anything, you should write the number 1 just so you don't forget. So now this 3 is going to distribute to every single thing here. This one, this 4, and this one right there. So when I do that, and I'm going to back this up so just so you can see, we're going to have 3. Now, a power to a power, you multiply. So 1 times 3 is 3. Now, x to the 4th, 4 times 3 becomes 12. And then on the bottom, that's 4 to the first power, so it becomes 4 to the 1 times 3, which is 3. Now, where I see students make mistakes is a lot of times they'll multiply this 3 and this 3 together. You are not multiplying the power times the base. You are multiplying the power times the power, which is 1 in this case, right here. Okay, so you got to be very careful about what you're multiplying. Make sure you're multiplying the correct thing. So now what you see is we have this new expression, 3 to the 3rd. So 3 to the 3rd is 3 times 3, which is 9, times 3, which is 27. And then we have x to the 12th. And then on the bottom, we have 4 to the 3rd. 4 times 4 is 16, and 16 times 4 is 64. And so then the final solution here then is going to be 64. So we have 27x to the 12th over 64. Now the next one, number 4, I have 3 more for you. Number 4 here, you can see we have 5x to the 5th y over 6, and then all of that is being taken to the second power. And same as the last one, if you don't have any exponents in there, you really should draw the first power in first on anything. And then this 2 is going to go ahead and distribute to every single power. Remember, it's only multiplying the power. It's not multiplying the base. So when I do that, I'm going to get 5 to the second, x to the 10th, y to the second, over 6 to the second, just like that. Okay, so that 2 multiplied every one of those powers. Now I'm going to simplify this a little bit. So 5 to the second is 25. Still having some issues with my stylus. I apologize. And then x to the 10th, y to the second, over. Now 6 times 6 is 36. So that is going to be my final answer right there. 25x to the 10th, y to the second, over 36. Okay. Now, number 5, we're going to simplify, and we're going to use the 0 property that I showed you above. So remember, anything to the 0 power is 1. I'm going to show you why this is so helpful, because anytime you see any variable or number to the 0 power, you can simply cross them out. They don't need to be there anymore. So that automatically simplifies this expression now to just having b's and c's. Now the b's and c's we have are being divided, so we would subtract them. So it becomes b to the 4 minus 2, which is 2. And then the c's, remember, if there is no power, it's a 1. So the c's you can see are 2 and 1, 2 on top, 1 on the bottom. So it would be 2 minus 1, which is 1. And there is your final answer for number 5. B to the second, C to the first. Now, the last one I'm going to show you is actually looks very complicated, but it's the easiest one in the whole set because anything to the 0 power is 1. So what you see is this entire huge expression here is all to the 0 power, but when you take that all to the 0 power, it simply equals 1. So that one is done. So there you go, guys. I hope that made sense. As always, if you have any questions, feel free to email me. Have a great day.